Good evening students. Today I am going to explain a very popular theorem, that is every field is an integral domain. So I have already explained the property of the field and the integral domain in my previous videos. In this video I will explain that every field is an integral domain. So we already know that some properties of the field and the integral domain, that every field have some properties, and it means a field is a commutative ring with unity, and in integral domain there is a property, that is the zero divisor property, that we see in the integral domain. So now we will see the proof that every field is an integral domain. Now since a field F is a commutative ring with unity, therefore in order to show that field F will be an integral domain, we have to show that field F will have no zero divisors. So if we want to show that every field is an integral domain, we have to show that this field will have no zero divisors. Now if suppose two non-zero elements, let A and B belongs to F and AB equals to 0, in such a way these are two non-zero elements and the product of this is 0 and A is not equals to 0. Now first we are saying that AB equals to 0 and A is not equals to 0. If A is not equals to 0, if A is not equals to 0, A inverse exists. Now since AB equals to 0, this implies A inverse AB equals to A inverse 0. We can write in this way. It implies A inverse A into B equals to, this comes out to be 0, and A inverse A, this is 1, this will be 1 into B equals to 0, and this is B equals to 0. It means if AB equals to 0 and A is not equals to 0, then if A is not equals to 0, then B will be 0. Similarly, if AB equals to 0 and B not equals to 0, now we are saying that B is not equals to 0. If B is not equals to 0, if B is not equals to 0, it means B inverse exists. If B is not equals to 0, obviously there will be B inverse. Now, since AB equals to 0 implies that B inverse AB equals to 0 or B inverse 0. It can be written as like this, and this implies B inverse B A equals to 0. This will be 0, and now this B inverse B, this will be 1. So this is 1, A equals to 0, and this is A equals to 0. Now see, when B is not equals to 0, for this AB equals to 0, then A is 0. It means when this is not equals to 0, it means A will be 0. Therefore, if AB equals to 0, then A equals to 0 or B equals to 0. If we are saying that AB equals to 0, then this is the condition that there either A should be 0 or B should be 0. But in field there is no non-zero elements, and the product of this is not 0 because that is without 0 integers. Without 0 divisors, it means this field is without 0 divisors, then that's why we can say this will be the integral domain. Therefore, obviously we can say that F is without 0 divisors, because we have proven that if AB equals to 0, then either A will be equals to 0 or B will be equals to 0. Therefore we can say every field is an integral domain. So we have proven this, that the field is an integral domain. Thank you.